This video is another one on integration by parts, which I've called Unit 2, and it contains 5 examples numbered 6 to 10. The numbers 1 to 5 were contained in the first unit. So starting off with number 6, and the integral we want to find is the integral of x multiplied by log n of x dx. So using the rule for integration by parts, we'll actually, in this particular case, before we go any further, reverse the order of integration and have that down as log n of x times x. Okay, and then apply the rule for integration by parts, which will be the first, which is log n of x, times the x integrated, which is x squared over 2, minus the integral of log n of x differentiated, which is 1 over x, times x integrated, which is x squared over 2 dx. And then on the next line, just tidying up a bit, that will be x squared over 2 log n of x minus half the integral of x dx. And then continuing, that will be x squared over 2 log n of x, and then the integral will be minus a half times x squared over 2 and plus the constant c. And then finally just tidying that up, that will be x squared over 2 times log n of x minus a half plus c. So that deals with the first one. The second one, or rather number 7, will be integral of cos x multiplied by 1 plus log n sine x dx. Again here, as in the first example, I've reversed the order of integration. So we'll have the 1 plus log n of sine x first and the cosine of x second. So applying the rule, write down the first, which is 1 plus log sine of x, and then integrate the cos x, which is sine x. And then minus the integral of the first one differentiated, which will be cos x over sine x, and the second integrated, which will be the integral of cos x, which is sine x. The sine x's will cancel out, and so on the next line we will have 1 plus log n sine x times x minus the integral of cos x, which is and then minus sine x. And then the sine x's cancel out, just leaving us with sine x times log n sine x plus c. So that deals with number 7. Moving up to number 8, that's integral of tan inverse x dx, and I'll do what I've done before, which is write that as tan inverse x multiplied by 1 dx, and then apply the rule for integration by parts. So that'll be the first, which is tan inverse x, multiplied by the second, or rather the integral of the second, which is x, then minus the integral of tan inverse x differentiated, which would be 1 over 1 plus x squared, times 1 integrated, which is x dx. And so continuing, we got x tan inverse x minus, and I've altered the integral slightly by taking a half outside and having a 2x in the numerator there. That's in order that the numerator is now the exact differential of the denominator. And so we now have on the next line x tan inverse x minus a half log n 1 plus x squared plus c. That deals with number 8. Number 9 is x times x squared dx. So applying the rule, we'll have the first, which is x, times the sec squared integrated, which is tan x, minus the integral of the x differentiated, which is 1, times the sec squared integrated, which is tan x. And the integral of minus tan x is simply log n cos x. So we have on our next line x tan x plus log n cos x plus c. That deals with number 9. Number 10 is a fairly simple integral, but if a rather lengthy, and you've got to be very careful about your minus signs in this one. So starting off, we have x cubed cos x dx, and then that will be x cubed, that's the first, and then the integral of the second, which is sine x, minus the integral of x cubed differentiated, which is 3x squared, and the cos x integrated, which is sine x dx. Next line, x cubed sine x minus 3, I've taken the 3 outside, and then integrated again with using the integration, the parts rule for integration. That will be the first, which is x squared, times the sine x integrated, which is minus cos x, and then minus the integral of the x squared differentiated, which is 2x, times the sine x integrated, which is minus cos x. And then the next line, that's x cubed sine x plus 3x squared cos x minus 6 integral x cos x. Right. And then x cubed, next line, x cubed sine x plus 3x squared cos x minus 6, and then using integration by parts yet again, that will be the first, which is x, times the integral of the second, which is sine x, minus the integral of the first differentiated, which is 1, times the cos x integrated, which is sine x. And so on our final line, we'll now have x cubed sine x plus 3x squared cos x minus 6x sine x and minus 6 cos x. That completes it. So we'll have another 5 to come in unit number 3, and thank you for listening so far.